Hi guys, so what we're going to do today is we're going to learn how to use trigonometry to solve for unknown angles. So a little bit different. What we've been doing so far, we've been solving for sides that we didn't know, so we always called the sides x. Today what we're going to do is we're going to determine the measure of the angles. So for example, in the first one here, what we've been doing the last few days for theta, we always had an angle in there. So 30 degrees, 42 degrees, 37 degrees, it doesn't matter. So we always had an angle. Now we have a theta. So what we're going to do is we're going to be working backwards. So we're going to undo the sine on this guy. So on my calculator, what I would do is, I'll show you on mine here. So on my calculator, right above my sine button, I have a sign with, it looks like it has an exponent of -1. So that's actually called the inverse sine. So what I do to work out the first one here is I would press on my calculator, second function, yours might look a little different, might be shift, second function sine, and then I'm going to type in that number. So 0.3297. Okay, on my calculator, well, you don't have to close the bracket, but you might have to close the bracket on your calculator. Hit enter, and that will tell you the angle. And we're going to measure to we're going to round to the nearest whole degree. So I'm going to put 19. The 2 tells the 9 not to round up, just to stay at 9. So my answer here for theta is going to be theta equals 19 degrees. So that's my units and everything included. For the next one, I'm doing cos theta, so I'm going to press not second function sine, but I'm going to press second function cos, 0.0946 equals, and it tells me 84.57, blah, 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 blah. The 5, I'm going to round up to the whole angle, so the 5 tells the 4 to round up to a 5. So I'm going to have theta equals 85 degrees. Okay, and then for the last one, it's tan, so I'm going to press second function tan, and then I put in 0.3422 equals, so it's going to be 18.89 degrees. The 8 tells this 8 to round up to a 9, so I put theta equals 19 degrees. And that's all there is to it for those ones. So for the next ones, a little more complicated. So now we're not just punching it into our calculator, we actually have to do it. So we're given the unknown angle, or we're given the sides, and we need to find the unknown angle theta, and it needs to be to the nearest tenth. So the first thing I do, just like we did before, I label the sides. So on this guy, I know the hypotenuse is always across from the right angle, so this guy is the hypotenuse. Adjacent means beside, so beside the theta is adjacent, so this one is adjacent. And the other one, only one left, is opposite, and it's opposite the theta on the opposite side of the triangle, so this is the opposite side. So then just look at the chart at the front of the room, and I know I have the opposite and the adjacent. I don't care about the hypotenuse, so we look at the chart at the front, and that tells you to use tan. So we're going to have tan theta equals opposite over adjacent. So that would be your free mark there for picking the right formula and writing it down. Then all I do is I substitute. So opposite is 4.1, adjacent is 2.3, so I'm going to have tan theta equals 4.1 over 2.3. What do I do with these guys? I divide, so I make this into a decimal. So I go top divided by bottom. So on my calculator here, I go 4.1 divided by 2.3. So I get 1.78. That's good enough. So I'm going to have tan theta equals 1.78. Then what I need to do is I need to get the theta. So just like we did up on the ones above, up here, which you can't see right now, I'm going to press second function tan on my calculator. So second function tan, and then I put in the decimal 1.78, and that will tell me what theta is. So 60.67, that's going to round to, what do we need to the nearest tenth? Tenth is one decimal place, so 60.6, the 7, that tells it the 6 to round up, so it's going to be 60.7 degrees. So I'm going to have theta equals 60.7 degrees. 60 box that guy. And we're done. So let's move on to the next one. So the first thing we do is always start off by labeling the sides. So across from the right angle is the hypotenuse, so this guy is the hypotenuse. Beside the theta is adjacent, so this guy is adjacent. And the one that's on the opposite side of the theta is the opposite. So now, we don't care about the adjacent. I'm going to cover that one up. Look at the chart. We need something with opposite and hypotenuse, and that is sine. where it's sine theta equals opposite over hypotenuse. I know that the opposite's 20, the hypotenuse is 25, so I'm going to write those in. Sine theta is 20 over 25. Just like we did over in this one, I divide these two, so I'm going to go 20 divided by 25. So that gives me sine theta, and 20 divided by 25 is 0.8, so I'm going to have 0.8 here. And then to figure out the theta, so we're looking at 8. So to figure out the theta, I'm going to go second function sine 0.8, and that tells me that the angle is 53, and we need to the nearest tenth, so 53.1 degrees. So theta is 53.1 degrees. Safety box that guy, and we're done. So 2 down, 1 to go. For the last one, same deal. Start off with labeling the sides. So the right angle, it doesn't show it on this one, but I'm pretty sure that's the right angle. Across from the right angle is the hypotenuse, so this one's the hypotenuse. Beside the theta, or adjacent to theta, is adjacent, so this is adjacent. And opposite is on the opposite side of the triangle from the theta. So now, I don't care about the opposite, because I don't have that side. So I'm going to cover that up. Look at the chart. Adjacent over hypotenuse, that would be cosine. So I wrote down the cosine formula. The cos theta is equal to adjacent over hypotenuse. So I have cos theta. The opposite side, or sorry, the adjacent side is 11. The hypotenuse is 17. Just like I did in the other ones, I'm going to change these to a decimal. So 11 divided by 17 on my calculator, which is 0.65, or if I round that off, so I have cos theta is 0.65. And then to figure out the theta, I press second function cos, 0.65, and I get 49. It's 49, I'll show you what I got here. 49.45. And I'm looking to round to 1 decimal place, so the 5 tells the 4 to go up to a 5, so this is 49.5 degrees. Safety box that guy. And that's what we've got. So we were able to solve for the angle in all 3 of these. For the next one, example number 3, and pause it where you need to, rewind it where you need to. So this one's a little more abstract, meaning it doesn't give us a picture. It's harder to see what to do. So in triangle DEF, angle E is a right angle, and length DF is 13.4, and DE is 11.9. Determine the measure of angle F to the nearest tenth of a degree. So what we need to do is for something like this, draw a picture. So I'm going to draw a triangle, and I know E is a right angle. So here's my triangle. E is a right angle. So there's my right angle at E. I know that DF, they tell me what DF is. It doesn't matter where I put D and F. So here's D up here and F there. If you switch it, it won't matter. It'll look different, but you'll get the same answer. So I know DF is 13.4, so this is 13.4 centimeters. And I know that DE, so here's DE, that's 11.9 centimeters. So this is 11.9 centimeters. And it wants me to figure out the angle, the measure of angle F. So the measure of angle F, that's where I want to find it. That's my theta, is where F is. So just like we did above, once we have the diagram, label the sides. Across from the right angle, that's the hypotenuse. Beside the theta, or adjacent to the theta, that's adjacent. The opposite side of the triangle from the theta is the opposite. So then I figure out which one I need. So you look at the chart. I don't care about the adjacent. So opposite and hypotenuse, that's sine. So sine theta is equal to opposite over hypotenuse. That's a mark. And substitute in for opposite and hypotenuse. Sine theta is equal to 11.9 over 13.4. I need to change that to a decimal. So 11.9 divided by 13.4. I get sine theta equals 0.889. And once I'm there, just like we did above, second function sine 0.89, and I get 62 point, rounding off to the nearest tenth, so I'm going to have 62.9 when I round that off properly. Safety box that guy. Okay, so pause it where you need to, rewind it, go back to see what you need to see, and you should hopefully be able to solve these independent practice questions on the next page. So you should be able to do all these ones on the next page. I hope that helps. Good luck.